Hello, welcome back to Pandas Tricks series. This is a part 2 of the series. In the part 1, you have recorded 1 to 10 tricks, and now we're going to record another 10 tricks, which can make your data processing with Pandas a bit easy and more productive. Okay, let's get started with trick number 11, correlation matrix plot with Pandas DataFrame. This one most of you are already aware of. I'm going to use a breast cancer data set for this. Hope it is visible. Okay. I have in the previous session I have just basically recorded or simply declared a bunch of data sets into variables as a first cell. So I'm going to use the same thing now. So rather than all of these are available in the GitHub, so it will be easy. Okay, so here we go. I'm going to just use a variable rather than the entire path. Breast cancer, all right, and looking at the correlation is actually a straightforward function. You can say correlation, and then we go. And the beauty is this is a data frame, which means you can slice, you can dice, you can do other things. More importantly, looking at this massive data set, I don't know which variable is related to what. It's better you color code it. I think we have done it before in a similar manner. I'm going to use a style and then say background gradient. Okay. And just use a simple helper function, helper key tab to fill it out. And I can use any color maps. I'm going to use cool warm. That will give us, the more correlation, the high correlation into red, and which are significant for us, and other things in blue or gray, which is not significant. There are multiple color CMap option, color map options. I also like Twilight. There are plenty of it. You can use blue, green, all kinds of things. You can just Google for it. CMap. I can just type in CMap or Pandas or even Matplotlib. So you will get a bunch of list of Matplotlib. The variations. So this is what I used before. Twilight is cyclic. We have many other things. We can actually have sequential color maps and so on. Okay, you can play with that. So this gives you, I rather like the cool warm. This gives you an easy way of finding out which variables are highly correlated. In this case, I can see that the mean radius and mean parameters have 9.99, which means they are very much the same variable from a variance perspective. In a real data processing, if you're doing, it's highly collinear, which means you should drop one or the other if you're doing with algorithms like linear regression. All right, so the next trick, import a number column as a string. Well, you might wonder, why would we even need this? Well, let me just take another data set, grade CSV, and okay, so let me take the Superstore orders one, and let me look at if I can find something which makes sense to explain this trick. Okay, we got it. All right, so look at here. There is a postcode. Postcode is of course a number, but it's not. It's not a float. I can say. Sometimes you might have variables like ID of a customer or an order, which are purely numbers. It might even have a zero, starting with a zero. If you give it to Pandas read CSV, it's going to assume it's a number and probably chop off the zero at the front and make it like a float or something like, which does not make sense. You might even lose data. So sometimes we might need to read a column as a string, even though it's a number, because it is not a number. It's basically a numbers label or some kind of string column. You can do that by simply saying here as d type, and I can pass on a dictionary where I can mention the column and the data type. In this case, I'm going to say postal code, and the value, I mean the data type I want to do it is string. I mean I can also mention as object a string. All right, so let's see what happens. Okay, and you can see that the postal code does not have a float, and of course you can check with an info to see whether the postal code has been taken as an object. And if you don't mention that, it actually took it as a float, right, which is not desirable. Okay, so that's a small trick which can help us come handy sometime. All right, so then you have another one, the trick number 13, which says read a data column from data as an index. Again, you might wonder why it is, so let me take why it is required. Let me take another data cost sales. I hope I have that cost sale. I don't know if I have the data. Let me check. It's way above. Oh, I do not have it. So let me just put it down right here. I have a data set called as cost sales, which basically captures the cost data or cost sale data of every month for I think 2 or 3 years. I hope it is there in the GitHub at least. If I'm not wrong, it should be cost sales. So we will find out if it is really exists, or otherwise I need to upload it. It's quite familiar. All right, so let me see cost sales. Let me first check if it is available. Oh, luckily yes. So this is a very small data set where you can see that only 2 columns. First one is a month. It starts with 16th of January, and the number of car sales is 266. And I could also find out how many records we have. So we have 36 records. So I guess it is 3 years data. So possibly 2016, 17, and 18. Okay. Now I know that month is actually a date, right? It doesn't have a day, but it has a year and a month. We might actually sometimes need this as an index. So the way you can do that is by simply mentioning index underscore column, which is one of the parameters of your read CSV or read anything in pandas. And I'm going to say it's a month, all right? Okay. So what it does, it literally made the column as an index, okay? But it's still not enough because this is a string. I want to tell pandas that it is a date. So I'm going to use a parse dates, I guess. Let me check. No, it's not giving me option. So parse dates. If it fails, then I can give multiple columns. In this case, only one. I can just give that column directly. I'm saying that this column is a date, right? Let's see. Yeah, so you can see that the pandas has processed this as a date, right? And you can already see it has taken the first of every month because there was no day mentioned in the date. It only year and the month. So it has taken the first of every month as a default, all right? Why you need this? Well, if you want to plot this one, for example. Oh, sorry, it should be a semicolon. Okay, you can see that it already have recognized this, index as a time, and it has nicely plotted the sales. I can see that sales is going up, which means the business is doing good. And this is made possible because I made this column, which was the month column, as an index, and also ensure that the column is read as a date, so I can right away plot it. So it's very much useful when you're doing a time series and stuff like that. That brings us to trick number 14, I only want to read a specific column, right? And this is useful for many reasons. One, you don't want columns, or maybe this data contains a lot of columns, you're only interested in specific columns, all right? Or sometimes you might have a column which has a lot of data, maybe some text, large text, and that's actually gonna eat away your memory, which you'll end up getting a memory problems. So I only want to read a certain specific column. I can do that by let me first get another data set. I'm going to use another data set for this. Okay. I have used this data set before as well. I assume that you are aware. So it's a data set which contains a lot of information about citizens and the category they fall, whether they have salaries less than 50,000 US dollars per annum or more than 50,000 US dollars per annum. I'm only interested, let's say, in few of the columns. Let's say work class, age and education, and race, for example. I can do that by simply using a parameter in read CSV. Use columns. I guess that is right. Let me just check. Yeah, that is correct. Use columns. I find it very handy. Most of the time when you work with the production data, you do not need to import the entire thing and then select stuff. You can do that. You are wasting the time, and also it consumes a lot of memory. You can simply specify the columns you need, right? So I'm going to specify age and work class and education, and just to show you an example, so I'm just going to stay with this 4, and if you read it, you only imported the 4 columns, which is very clean. So you can read only specific columns using Pandas read CSV. Okay, and then you have a 15th trick, finding the percentage of records with missing values. Finding number of missing values is a different thing. Well, let's take a data set. I have created a specific set called empty chars with missing, just to help us to do things better. So we have missing values, nan. We also have dollars and question marks and stars and stuff like that. First of all, let me replace them in one go. I'm going to say the dollar and a star, and I guess there are many, but let's just do it a rough patchwork. A question mark with a nan. So before that, I think I need to import my numpy. Oh, I think numpy is already imported at the top. So I can simply use np nan. I'm going to say in place is equal to true, so that the change becomes. Okay, so I can see that all the special characters have been replaced with nans. When I do like data is null, you get all the null, and then you can simply sum it up. All the trues convert to 1, sums up. Nicely gives you that we have 9 missing values in displacement, 1 in mileage, 9 in displacement. But these are column-wise missing values. Okay. And well, what I wanted is I wanted to know how many records we have with missing values. You might question why we need the data. Well, if there are less than 5%, for example, less than 5% missing data, I could even remove or simply drop those records rather than going for imputation, like replacing the missing value with some numbers with a forward fill or backward fill. If it is less than 5%, which means we have most of the data, we could literally drop the records, the entire records directly, and move ahead. Sometimes it's more accurate or better for the modeling when compared to the imputing with missing values with some guessed values. To do that, I'm going to use a simple shape function. The shape attribute, of course, it returns a tuple which has a number of records and a number of columns. All right, and we know from our previous knowledge that when you say drop NA, it simply drops all the records which has any missing value. So I'm going to simply say shape of this one. That's given me 11 records, which literally means we have about 21 records missing. That's quite significant. I want to know the percentage in a more generic way. The way we can do it by simply using this tool, I could simply say that data.shape. I mean, the shape, I'm only interested in number of records, so I'm going to go for the first value by putting a all right, and then simply subtract it from. Remember, when you say drop NA, it's only showing, like, it's not really dropping, it's showing what it looks like when it drops. It only drops when you say in place is equal to true, so no damage. No damage. And I'm going to just take a percentage of it. The percentage, you can take it like this minus this divided by, okay, so the actual one. Okay, so this is the amount of missing values. As you can see, 65%, well, I can multiply the percentage into 100. So it's 65.6% missing values. And this statement works for any data set because we haven't really, I mean, we simply use a shape. So it's interesting. It's interesting data from analysis perspective. Well, you can achieve this using many other ways, but this is one of the simplest ways. So I find this easy sometimes. All right, so that's how you can find the percentage of records with missing values. All right, then we have reading multiple files. When you do projects which is related to IT security or networks or anything related to server, predicting server loads and stuff like that, we have to read a lot of log files, right? You deal with log files, and these log files are usually for every hour you have for every day you have a log file being created, and you have multiple log files being created. Most of the time we need to club them together, all the files. There might be hundreds or thousands of files, data, with very consistent columns, but we need to club them. So let me show you what I mean. Okay. So just assuming that there is a log files in my directory. Fine. Okay, luckily yes. So we have a log file of 15 February 2018, and this looks like this. It's a text file which, okay, so it has an IP number, it has a time, it has an URL, which I think it's a website log, request log URL, and then you have a status, whether it is served or not served or whatever it is. Okay, so this is a kind of thing you need. So I have a lot of files like this. In this tutorial, I have 5 files like this: February 15, 16, 17, 18, or something like that. I want to club all of these files together and load it in one time. I can do that by using glob, which can essentially, okay, let me just say from glob, import glob. Okay. So when you say glob, and I can just give a star or something, so it basically retrieves all the files in this working directory. You can give any path you want. You can give a network path or any path, and you can find basically reads the directory structure. Right. I'm interested in only log files. So these are the files I'm interested. There are 16, 17, 18, 19, okay, 15, 16, 17, 18, 19. They are not in order. I mean, I would like to have it in order. So first I'm going to simply, this is a list. So I can simply store this as a files, and then I can simply sort it because it's a list. Then you see that we have, okay, I should display it, sorry. We have a nicely sorted log 15, 16, 17, 18, 19, 5 days of data. All right. Then I'm going to use read CSV, or data is equal to, I'm going to use concat function, and concat function can essentially concat or concat the different data frames. So I'm going to say pd read csv and file, and I'm going to run an inline for loop for file in file. So what I'm asking to do is go through these files and just get one file name at a time and read it, and then it makes a bunch of data frames which needs to be clubbed together by concat. Okay, and I hope this runs without any. Okay, so before even doing this, let me just look at how many files you have in like each of these files. CSV. I'll take any file, let's say first one, for example. So we have 20 records in each file. I guess the same 20 next day as well. If I'm not, yeah, not same. Some has 20, some has 33 in that kind. All right. So let me just do it. Okay. So now we don't see what happened. So let me see how much data we have by using a shift. Sorry. We have 184 records. So essentially, it clubbed all the records, nicely put in one. One problem you might actually face, let me just say 25, then you can see the entire thing. It is restarting the index because this is that's the next file, all right? To prevent that, you can simply say ignore index is equal to true. Index is equal to true. Then you will not see the problem. So it nicely blends. The 20 till 20 is the first file, or 19 is the first file, and then you have other next file which is coming up with its own data. So this simple statement can actually go through hundreds of files or even more, given that they have a very similar column structure. Typically, when a program generates a log files, that's the case. So you could use this single line to actually read hundreds of small files, make it a one data frame, and then process it. I find this really helpful when I'm doing network-related projects or cybersecurity projects where you continuously look into the logs, then try to see if there is any phishing attempts or Daniel of DOS attempts on your server. All right, so that's your 16. Then trick number 17, rearranging numerical and categorical columns. Okay, so let's get some data again. I'm going to use the same adult data set. Okay. Okay, so this is the same data set which I just used. Many a times you would like to have all the numerical fields at one side and categorical fields at the other side. It helps in many ways. All right. So how do you do that? Well, you could manually do it, but if you have a lot of columns, that will take up a lot of time. So we have a nice function in pandas. Okay, this is data, isn't it? So data colors D, select D types. Basically, it's telling that select data types. You can select a specific data type, and only those columns with those data sets will actually be listed. So there are many parameters, useful ones. Include, I can say include object, it's basically string elements. So object, if you do this, you see that only categorical data has been, the one which has text, which is object data type, is being selected, all right? That's very helpful. I can simply do again a concat. I use this one here, and then the next one I'm going to just copy the same thing, but this time I'm going to say exclude. Okay, close it up, and then concat has to be okay. Hopefully correct. I have to say access is equal to 1. Sorry. So I'm going to concat this on column wise. So if you don't give it anything, it's essentially it says access is equal to 1. 0 is the default, and it's trying to concat row wise, so record wise. I want to concat the column wise. I want to put the two data frames like this. So I have to say axis is equal to 1. Then you see magically all of your categorical variables or the text variables are coming first, and then you have all the numbers coming after. This might prove very helpful in data processing. Okay, so that's your trick number 17. Now the trick number 18. Label encoding multiple columns. Well, we just have the multiple columns. Let me just store this data into a data. So I'm just overwriting our data frame, and you could see that. Okay, so you could see the benefit of the previous trick right away now. Right, I have all the categorical data at one place. I'm going to use one single command to label encode the entire thing. Well, if you are doing for production, you have new data coming and you have to re-label encode it, re-transform it, then you have to store the label encoders as a list. But if you're doing it one go for checking the accuracy, fine-tuning and finding out how much you can achieve, well, that's how we always do. First we do it like one go, then if things are fine, then we can just change the code. Okay, so what I'm going to do is I'm going to simply use LOC and pick up all the records and columns. I'm going to use a slicing, saying from work class, which is this one, till the category, which is the after that you have numerical fields. All right, and I'm going to say dot apply. Let me just import the label encoder from sklearn preprocessing import label encoder. Okay. And I'm going to say label encoder object, and I say fit transform. Alright, so I'm going to right away replace this to itself. Okay, let's check what happened. Okay, so beautifully with one line again, we managed to label encode all the columns. And if you're a beginner, you would have struggled label encoding multiple columns, writing several lines of codes. Well, you don't have to do it. You can simply get all the columns and rows of the text fields into one side by using the trick which I explained above, the 17th trick. And then you can just simply say select all the object columns by slicing, because they're all together now, and then apply. Simply one statement, apply this function which fit and transform, and one line, your work is done. It proves really effective, reduces a lot of number of lines, especially when you have many columns to be label encoded. Alright, so that's trick number 18 and trick number 19. There's also correlation between features and target variables. So let me tell you what it is. I'm going to take a breast cancer data set. Breast cancer. Okay, so breast cancer. 30 columns. Just going to print the shape of it. We have 569 records and 31 columns. All right. The last column would be whether canceric or not. All right. Okay, so I want to find which variables here are actually affecting a patient to have a cancer or not cancer. Which variables are highly correlated with my target, which is cancer or not cancer. All right. You could simply use your correlation. And I can just go through it. You can apply colors. We just have done before, the heat map, the color maps. What I would like to do, I'm going to take this whole thing into another data frame. This is a data frame. I'm going to say data frame correlation. I'm going to simply store this into a data frame now that it is a data frame. Okay, I'm going to say target or outcome, I guess. What was it? Yeah, outcome. This gives you a straightaway relation between every single feature or the variable with the target, all right? And on this, you could also do the sorting. For example, I can say sort values. So, well, I can also reverse it and say ascending is equal to, okay, ascending is equal to false, which makes it, okay. So now I can say, of course, outcome with outcome is actually 1, and then these are the features like worst concave points, worst perimeter, mean concave points, worst radius have the highest correlation. You can just look at it, it's nicely sorted, and you could say it is like top 10 or 15 or top 10 or the highest, and maybe you can do the modeling with only these and see if it gives a better accuracy. All right, so this is a simple statement of, you know, essentially storing the entire data correlation into another data frame and using that variable and sort it. You can also do other slicing things. This is really simple and helpful. Okay, it simply lists the top variables, features which is affecting your influencing your target variable. That's the trick number 19. And trick number 20. All right, so many a times, well, including the data above, we have this breast cancer data. You see that the column names have some special characters, like you have space here. You might have something else as well. Let me just put one weird, you can use, I'm just using rename. Columns is equal to dictionary. I'm gonna say mean radius into something slightly even weird, mean, and then I put a star and radius. I don't know why it is star, whatever it is. I'm going to say in place is equal to true. Just want to create a little bit more tricky data frame with. You can see that there's a mean and then a dollar, and you have this kind of special characters in your variable name. You cannot refer them like I try to, like you cannot refer them like saying data dot, I can just refer, let's say mean, and you cannot refer that or any radius or whatever. So because there is a special character in the column name, which is not a qualified name, you cannot use it. So well, this is often a case. Then you have to use for LOC and you know, filtering and stuff like that, and you can still do it, but it looks like ugly. It's not very convenient. So you can use a simple trick here. I can use a regular expression to replace all of the, you know, the column names with an underscore, which is a qualified character. So let me try that. I'm going to say columns and then string, say replace. Does replace work? Okay. Now let me just try that. I'm going to replace a space with an underscore. Okay. Okay, it does work. You can see that all the spaces has been replaced by this one, so it's pretty effective. I can simply directly reassign it to the columns again. But I have this thing. I mean, this is also not. I don't like it. Any special characters, then we have a problem. So gonna use a simple generic, not a word thing. So essentially, any special character comes into this. When I run this, you see that everything is gone. I mean, even the dollar is gone. Any special characters anywhere in the column names, it simply disappears and it's replaced by an underscore. Now I can simply overwrite my columns with this. Thereby, if you look at my data set, it is now nice and clean, and I can refer that by saying, let's say radius error or whatever. So you can get the value straight away. It's clean. So a trick here is to replace the columns by using this regular expression /w, which is used for special characters, and then I can replace that by an underscore. and then simply overwrite the existing columns. That is your 20th. Okay, yeah. Okay, so that's 11 to 20. In the next session, we'll look into more interesting things from 21 to 30 tricks. Stay tuned.